Hello, thank you for checking out my video, and today we're looking at how to make a table and equation given a linear situation. So we're taking a real world context and we're going to make a table, and then we're going to make a function and show that right here in real time here. So let's take a look at the first example. Okay, it says here Madeline is signing up for a gym membership with a one-time fee to join and then a monthly fee to remain a member. The one-time fee to join the gym is $100, and the monthly fee is $50. It says make a table of values and then write an equation for C in terms of T to represent the total cost of the gym membership over T months. Okay, so this is similar to a video that I had previously where I had a table out here and I was showing you the input and the output. Okay, so what you want to do here is say, okay, what is the total cost after whatever the number of months? So what do we start with? Well, we start with $100. So before you even start a whole month, you have to pay the $100, the one-time joining fee. So at 0 months, you're already at $100. So you just type that in. All right. So then the next thing you want to do is like, okay, well, how much money have you spent after 1 month? So the next month is another $50 added on to that 100. So you got 100 plus 50, which would be 150. All right. Then the next thing we're gonna do is add another $50. So you add another $50 of that, and you're looking at 200. And then another $50, you're looking at 250. Simple enough, right? Cool. Now it's wanting the equation. So what is the equation? Well, it depends. The independent is the number of months, and the total cost depends on how many months we are there. So you're gonna multiply the months by a constant rate. That constant rate is $50. So you start off with 100. Okay, and then you're going to add $50. And we'll add $50. But we're going to, we don't know how many months it is. I mean, we know what it'll be for 0, 1, 2, 3 months. But we can figure out like 10, 20, 18, whatever months. That unknown we're going to plug in is going to be T. Instead of using X, they want us to use T. So we're going to put T in for the unknown number of months. And that's your equation. So let's say it was 10 months. You'll do 10 times 50 and then add 100. Let's say it was 7 months. You'll do 7 times 50, then add 100. And that'll tell you the answer for the total cost of membership up to that number of months. So that's all we're doing on this. We're putting in this table and then writing the equation at the end. Okay? Now, I like to go over, especially from a real world context, start with where you begin with that $100 and go down from there. But as you look down through here, they'll show it to you in this format, 50t plus 100. And it's the slope intercept form that we talked about before, with the y being the c and the t being x. Y equal mx plus b. So the 100 is where you begin, and the 50 is how much you move, how you change every month. But you could write it either way, and it will take it. So let's take a look at another problem. All right, let's take a look at this next example here. It says, at the end of a snowstorm, Damien saw there was a lot of snow on the front lawn. The temperature increased and the snow began to melt at a steady rate. There was a depth of 15 inches of snow on the lawn when the storm ended, and then it started to melt at a rate at 0.75 inches per hour. Make a table of the values and then write an equation for S in terms of T, representing the depth of snow on Damien's lawn in inches, T hours after the snow stops falling. So let's take a look at this one here. So we begin the number of hours after the storm, okay? It starts off with 0. So at 0 hours after the storm stops, the snow is at 15 inches. So we type in 15. Okay? Then after an hour, it starts to melt there, or it starts to melt for an hour, and it decreases. That's a key word there. It decreases or goes down by 75 inches, or 0.75 inches per hour. So what we're going to do is take this 15 and subtract 0.75. Okay, so what I'm going to do is pull up the calculator here, and it's going to work out really well. So we start off with 15 and just subtract 0.75. And you see over here on the right, the answer is 1425. So you just type that in, 1425. Alright, now we're going to subtract 75 again, 0.75, because it's another hour. So now we're at 1350. So just type that in. I'll type 13.5. Okay, and just subtract 0.75 again. 12.75. And then we're good to go. Alright, so that takes care of the table. Now all we got to do is write the equation. So we're going to start with where we begin with. We begin with 15 inches. Alright, now we're not going up, we're going down. So we're going to subtract. So you put minus here. And then what are we subtracting? Well, we're subtracting the 75 cents, or 75 inches, 0.75 inches. Right? But it's multiplied by the number of hours after the storm, which is unknown, and they want to just use t as the variable. So you put t in. There you go. Alright, now if you look at this in terms of the slope intercept, they have it like this with the minus in front. So that's why that negative is right here, and that's why you have a declining slope there. Okay? If you look at this table. But that's it. This is how you make a table and equation given a linear situation. Again, I want to thank you for checking out my video, and have a nice day.